Okay, so I'm going to put up 2 videos for this one. Now, the first one, I made it a mistake. So I'll put this up as like the video you watch in class, and I'll add in an additional link if you'd like to see how I formulated all of this diagram and all of this stuff up until here. The only real difference is that I forgot to account for this force, and so I've had to chuck it back in on the end and recalculate that. But a car with a mass of 1,400 kilograms is pulling a caravan with a mass of 2,850 kilograms up a slope of 1 in 4. Now, as soon as I see that, I know that means that sine theta equals 1/4, which means that our angle we're working with is 14.48 degrees. The resistance to the motion of the car and the caravan are both 1/4 of their weight forces. So over here, I've worked out 1/4 of the car's resistance force, and I've worked out 1/4 of the weight resistance force for the caravan so that I have how much it's pulling back by. Now, this has to be the car and this has to be the caravan, because if the acceleration is going up that way, the car pulls the caravan. The caravan can't pull the car. That's not how that works. So, determine the tension in the tow bar and the tractive force exerted by the engine in the car if the car moves up the incline with an acceleration of 1 meters per second and it's moving in the positive direction. So first thing I did is I'm resolving this one here in the yellow. Now, I don't even care about anything that's happening in the J direction, so I didn't have to resolve anything for that. Because it's moving up in this direction, I care about all of the things that are parallel to the acceleration vector. So down here, my mass is 2,850, my acceleration is 1, and it's equal to the tension here is moving in the positive direction, so that's positive, minus the resistance force, minus this force down here. Now, instead of having this, you could have this instead. It won't make any difference at all. It's the same thing. Next one that we're going to start resolving is the one in green. So you can see there are 4 forces in total, and the only one that's moving in the positive direction is the capital F force. That's why down here I've got capital F minus this force. If you drop that paperclip thingy and you hit me in the head with it, it's done. Sorry. So, shame. Yeah, so these forces come from here, which is this component. It comes from the resistance force here, and it comes from this one here. So that's why I've got all of these components down here, and when you rearrange for F, you get this answer. Now, it is slightly different to the answer that you get in the textbook, but that's because they have gone with exact values and I've gone with rounding. So like I said, if you'd like to see more detailed how I got all the way up to this section here, and then I forgot to add on this resistance force, you can see that in the other video that's provided.